This is my differential analyzer. It's based on a design by Ron Fail many years ago now, but it's quite different. It's laid out differently, and the most important thing is that it uses capstan style torque amplifiers instead of the servo arrangement that Ron used. Ron, for some reason, thought that these couldn't be made from Meccano. That's not true. These are mine. They're quite crude. Other builders have made much more sophisticated versions of torque amplifiers. So we have two integrators and a plotter. All the connections to the various parts are done at the back, and the machine can be configured to do some different things. I just have it able to do two things: a test program which draws a circle on the plotter, and then by a couple of very simple rearrangements in this area, the machine's configured differently and it will draw a sine wave. So now we'll see it working. We're going to draw the test circle, and in that configuration the output of one integrator is connected to the input of the other, so the integrators are cross-coupled. You can see how much error there is by the way that the beginning of the circle and the end of the circle joins up. So we'll start it up. And we'll lower the pen onto the paper, which I should have done first. It's drawing a circle. The integrator wheels here are spinning on the disc. They're driving the input of the torque amplifier, and at the back the two sprocket and chain connections, that is driving the lead screw of this integrator and is moving the position of the disc. While we're drawing the circle, we'll have a look at the back plane of the analyzer. Here the output of integrator 2 is driving through the sprocket wheel the lead screw of integrator 1, and the output of integrator 1 through the chain again is driving the lead screw of integrator 2. Also, the output of the torque amplifiers are driving the plotter, integrator 2 through this long shaft, and some 1-to-1 gears is driving the y-axis of the plotter, and integrator 1 is driving the x-axis, which is the pen. The y-axis is of course the table. As the integrator wheel comes to the middle of the disc, needs a bit of help here, it will slow down to nothing, and then of course it will start to go the other way, and at that point you see that the circle is now being drawn in the opposite direction through a separate motor. This one, the drums are being driven from the torque amplifiers. You can see that there is a arrangement of gears that drives the two drums in opposite directions. One drum is active for one direction of the input and the other drum responsible for the other direction. The same thing with this torque amplifier, the two drums again running in opposite directions. Here we're getting close to the center of the disc again, so the integrator wheel is slowing down, and that is the 3/4 point of the circle. We're getting close to the end here, and I think we can tell that there will be some error, but it isn't too bad. I've got the machine now set up to draw a parabola. This is program number 3 for Ron Fail's machine, and I've set it to get the biggest parabola I can onto the paper. So here we go. The y-axis is the time and the x-axis is the value. The machine is now set up to draw a sine wave. That's using Ron Fail's program number 1. And this is the main motor for the machine. It drives the discs through these contrate gears, and it runs constantly, usually representing time. It will also run the x-axis of the plotter through this chain when required for certain tasks. It used to run everything, but it was overheating, and so I added this second motor for the drums of the torque amplifiers to relieve the load. That's why this motor looks like a little bit of an afterthought, because that is what it is. That's about it for the differential analyzer. Thanks for watching.